A missile raid at sea does not begin with an explosion. It begins with confusion. One radar return appears on the horizon. Then another. Then 20 more. Some are high. Some are skimming just above the waves. Some are ballistic. Some are cruise missiles. Some may be decoys. Some may be electronic traps. And before the human eye sees anything at all, a U.S. Navy destroyer has already started fighting. Computers begin sorting tracks. Radars begin refining them. The combat system starts deciding what matters most, what must die first, and what weapon gives the best chance of survival. On the most advanced American destroyer now at sea, that entire chain happens with a speed and precision that looks almost inhuman. That ship is not just armed. It is wired for violence at machine speed. And if you want to understand how the United States could build a destroyer capable of facing down a raid that feels impossible to survive, you have to start with one ship, USS Jack H. Lucas, DDG-125, the first Flight III Arleigh Burke-class destroyer. The U.S. Navy describes this ship as a major leap in surface combatant capability, built around the Spy-6 V-1 air and missile defense radar, and the latest Aegis Baseline 10 combat system. Naval Surface Force Pacific went even further, calling Spy-6 on this ship the most powerful radar ever fielded on a U.S. Navy surface warship. That is an extraordinary statement, because American destroyers were already among the deadliest air defense ships in the world before Flight III arrived. Jack H. Lucas is what happens when the Navy decides that the old shield is no longer enough. From the outside, a Flight III destroyer does not look radically different. It still has the lean, angular silhouette of the Arleigh Burke family. It still looks like the same steel predator that has defined American surface warfare for decades. But inside, the ship has changed in ways that matter. The Navy says Flight III required a major redesign in power and cooling to support the new radar and combat systems. In other words, this ship is not just a Burke with a better screen. It is a Burke rebuilt around the reality that modern missile warfare is now a contest of sensors, data, and reaction time. Whoever sees first understands first, and shoots first usually lives. Whoever hesitates dies. That is why Jack H. Lucas matters. It is the Navy's answer to a future where missile raids come faster, lower, smarter, and in larger numbers than ever before. The heart of that answer is Spy-6. According to RTX and NAVSEA, Spy-6 is not just another naval radar. It is a fully modern air and missile defense radar designed to detect and track an enormous range of threats, from ballistic missiles and cruise missiles to hostile aircraft, surface contacts, and even hypersonic threats. RTX says the Spy-6 family can simultaneously defend against ballistic missiles, hypersonic missiles, cruise missiles, anti-surface threats, anti-air threats, and jamming or electronic warfare conditions. That single word, simultaneously, is everything. Because a real naval attack will never be polite enough to come in one neat category at a time. The ship might have to watch the upper atmosphere, the sea-skimming layer, the airspace overhead, and the electromagnetic spectrum all at once. Spy-6 was built for exactly that nightmare. What makes Spy-6 so dangerous is not just that it sees far. It sees clearly. NAVSEA says it uses gallium nitride technology, digital beamforming, and scalable radar modular assemblies that improve sensitivity, adaptability, and long-range detection. RTX says the Flight III destroyer version, Spy-6 V-1, uses 4 fixed radar faces with 37 radar modular assemblies per face to provide continuous 360-degree awareness. That means the ship is not sweeping the sky like an old rotating antenna, hoping to refresh a picture before the next threat pops up. It is maintaining an active, all-around, constantly updated combat picture. In a saturation raid, that matters because the destroyer is not just trying to find targets. It is trying to separate real threats from noise, decide what arrives first, assign weapons, and avoid wasting precious interceptors on the wrong things. But the radar alone does not kill anything. What turns detection into destruction is the Aegis weapon system. The Navy describes Aegis as a computer-based command and decision system that makes the ship capable of simultaneous operations against multi-mission threats. Lockheed Martin describes it even more bluntly: a centralized, automated command and control and weapons control system designed as a total weapon chain from detection to kill. That phrase is important because modern air defense is not just a radar problem or a missile problem. It is a decision problem. A ship under attack must know what to shoot, when to shoot, how many to shoot, and whether to trust the first intercept or launch a follow-up. Aegis exists to compress that logic into seconds. It is the destroyer's brain, the part that allows one warship to fight like an entire network. This is also why the phrase 100 missiles at once starts to make sense. It is not about one spectacular cinematic moment. It is about being built to survive a raid scenario. The Navy's own Aegis fact file says the system supports simultaneous operations across anti-air, anti-surface, and anti-submarine warfare. The DDG-51 fact file says Flight 3 ships can simultaneously perform anti-air warfare and ballistic missile defense, giving them a true integrated air and missile defense capability. In plain English, this destroyer does not have to choose between protecting itself from an aircraft attack and protecting itself from a ballistic missile threat. It was designed to manage both. That is the key difference between a strong destroyer and a truly terrifying one. The terrifying one can keep fighting multiple battles in different layers of the sky at the same time. Then comes the magazine, the ship's teeth. The Arleigh Burke class uses the Mk-41 vertical launch system, and the official Surface Force Atlantic Destroyer class page specifically lists a 96-cell Mk-41 VLS on DDG-51 class ships. Those 96 cells are not all identical in tactical value, because they can be loaded with different missile mixes depending on the mission. The destroyer can carry the standard missile family, Tomahawk, Vertical Launch ASROC, and ESSM, according to Navy and Surface Force fact pages. That means the ship is not just an interceptor platform. It is a layered combatant that can defend itself, defend a task force, strike land targets far inland, and fight submarines. In war, that flexibility is lethal. But in a missile defense story, the critical point is this: the ship can pack a deep, versatile magazine for different threat bands instead of relying on a single weapon for everything. And here is where the number game gets serious. The Navy's ESSM fact page says ESSM Block 1 uses the Mk-25 quad-pack canister on Mk-41 equipped ships, which increases firepower and lethality. That means one VLS cell can hold 4 ESSMs instead of one larger missile. So while the ship physically has 96 launch cells, the actual number of interceptors can go far higher depending on the loadout. If a commander expected a heavy anti-ship cruise missile threat, some cells could be filled with quad-packed ESSMs for close and medium-range defense, while others could carry SM-2 or SM-6 for longer-range work and SM-3 for ballistic missile defense. That is why a destroyer can be described as capable of taking on 100 missiles. Not because it is carrying 100 giant long-range interceptors, but because its layered missile architecture can be tailored to handle a massive raid. Now imagine how that works in combat. The outer layer might involve SM-3 missiles for ballistic missile threats in midcourse. Another layer may involve SM-6 or SM-2 engaging fast air threats, aircraft, or terminal ballistic targets. Inside that, ESSM becomes the ship's knife-fighting weapon against agile anti-ship cruise missiles and other close-in threats. And even after that, the destroyer still has point defense systems like CIWS for the last desperate seconds. In other words, the ship is not betting everything on one magic shot. It is building a series of kill zones. If the first layer misses, there is a second. If the second fails, there is a third. If the raid leaks through, the inner defenses take over. That layered defense is how you survive saturation. Not by being perfect, but by forcing the enemy to run a gauntlet of overlapping death. And unlike internet mythology, the U.S. Navy does not treat this as theory. Tests it. One of the best examples came in Flight Test Aegis Weapon System 48, also known as Vigilant Wyvern. In that official Navy and Missile Defense Agency test, the Arleigh Burke-class destroyer USS Carl M. Levin, DDG-120, intercepted 2 short-range ballistic missile targets while also conducting an anti-air warfare engagement against 2 subsonic anti-ship cruise missile drone targets. The Navy called it one of the largest integrated air and missile defense events ever conducted in the Indo-Pacific area of responsibility, and said it was the first concurrent ballistic missile defense and anti-air warfare raid of its kind. That test alone explains why these destroyers are so feared. They are being built to manage multiple categories of incoming weapons at once, not one neat target at a time. And if that still sounds abstract, look at the weapon expenditure. In Vigilant Wyvern, the destroyer used 2 SM-3 block IA interceptors against the ballistic targets and 4 SM-2 block IA interceptors against the cruise missile drones. That is a layered, concurrent defense in one live-fire event. Not just one threat type, not just one intercept, a real, structured, multiple-target raid. The test also highlighted the Navy's IAMD priority mode, which integrates classic air defense with new discrimination and tracking capabilities to defend against coordinated simultaneous attacks. That is exactly the kind of system you would want if an enemy tried to overwhelm a destroyer with a flood of missiles coming from different vectors and in different flight profiles. It does not prove the ship has literally swatted 100 missiles out of the sky in one battle. But it proves the architecture behind that headline is very real. Another official test pushed the point even further into the ballistic missile realm. In FTM 31 Event 1A, the destroyer USS Daniel Inouye, DDG-118, launched 2 SM-6 Dual-2 missiles and successfully intercepted a medium-range ballistic missile in its terminal phase. The Navy said the test demonstrated that a ballistic missile defense-configured Aegis ship could detect, track, engage, and intercept the target, and that the upgraded capability was ready for operational use. That matters because a saturation attack is not always made of only low-flying cruise missiles. A modern destroyer may have to fight the upper layer and the sea-skimming layer nearly simultaneously. The more categories of threats it can handle, the closer it gets to that terrifying 100 missiles reputation. And this is where the destroyer becomes more than a ship. It becomes a fleet shield. In a carrier strike group, the destroyer is often part of the outer defensive ring. It may be stationed away from the carrier, watching a sector, feeding the shared air picture, and preparing to shoot before a threat ever gets close to the high-value unit it protects. The DDG-51 class is built for that role because it combines anti-air warfare, ballistic missile defense, anti-submarine warfare, and strike warfare in one platform. The destroyer's job is not simply self-defense. Its job is to help keep the whole force alive. That means its missiles may be launched to protect other ships, other aircraft, or even allied forces ashore, not just itself. In other words, when you hear that an American destroyer can take down a huge raid, you should picture a ship acting as a floating anti-missile fortress for everything around it. But no radar and no missile battery matters if the ship cannot process chaos under pressure. That is where automation and crew training come together. The official Jack H. Lucas article emphasizes that this ship is not just carrying new hardware. It is acting as the Navy's initial operational test and evaluation campaign ship, helping push the technology to sea under increasingly demanding scenarios. The crew is learning how to fight with Spy-6 Baseline 10 and the upgraded engineering plant that feeds them. That matters because missile defense is not a video game. The system may automate huge parts of detection and engagement, but human beings still set doctrine, choose priorities, decide how much magazine depth to spend, and determine whether to hold fire for a bigger threat that may still be coming. Against a raid, those decisions are everything. This is also why the phrase most powerful destroyer points more naturally to the Flight 3 Arleigh Burke than to the more exotic Zumwalt class. Zumwalt is a remarkable ship, but the official Navy and surface force material around current air and missile defense evolution centers overwhelmingly on Flight 3 Burkes and Spy-6. The Flight 3 design was built specifically to bring stronger integrated air and missile defense to the fleet. The DDG-51 fact file says Flight 3's core upgrade is the N/Spy-6V1 air and missile defense radar, giving it vastly increased capability over flight IIA ships and enabling simultaneous anti-air warfare and ballistic missile defense. So if the question is which U.S. destroyer is best suited to smash apart a giant missile raid, the Navy's own modernization path gives the answer. The Burke lineage did not stay dominant by accident. It stayed dominant because it kept evolving into the ship the missile age demanded. There is another reason these ships are so dangerous. They are not trapped in one tactical profile. The same destroyer that can defend against a major raid can also launch Tomahawk missiles for land attack, fire ASROC for anti-submarine warfare, deploy helicopters for scouting and submarine hunting, and operate as part of a larger networked force. This is crucial in real war. A ship that spends all its time and magazine depth purely on self-defense becomes predictable. A ship that can defend, strike, scout, and hunt is much harder to neutralize. An enemy planner has to assume that even while trying to survive an incoming missile wave, that destroyer may still be able to return fire against launch sites, aircraft, ships, or submarines. That makes the destroyer not just a shield, but a counterpunch platform. United States Navy Commander, Naval Surface Force Atlantic truth is that saturation defense is not just about missile count. It is about magazine management. If a destroyer had 96 cells but wasted its best missiles on the wrong targets, it could still lose. If it fired too late, it could lose. If it hesitated between tracks, it could lose. The real superpower of Aegis and Spy-6 is not merely raw capacity. It is the ability to help the crew choose correctly at combat speed. Which targets are real? Which ones are first to impact? Which ones threaten the carrier, the oiler, the amphibious ship, or the destroyer itself? Which interceptor gives the best probability of kill without wasting the deep magazine? This is why the system is described as integrated and automated. It is built to make impossible timing problems survivable. Now think about the psychological effect of that on an enemy. Launching a missile raid is expensive. It consumes precious weapons, intelligence, planning, and often surprise. If the raid is defeated, the attacker may have burned through a large chunk of its offensive power for little result. Worse, a successful defense by an Aegis destroyer tells the attacker something terrifying. The window of vulnerability may be gone. The first wave has already failed. The Americans still have radar. They still have missiles. They still have command and control. And now they know where the attack came from. In that sense, one destroyer surviving a heavy raid can flip the whole strategic picture. The attacker gambled on shock. The destroyer turns that shock into warning, and warning into retaliation. Still, the destroyer is not invincible. No honest analysis should pretend otherwise. A sufficiently large raid, especially one mixing deception, jamming, ballistic weapons, cruise missiles, drones, and coordinated timing, can stress even the best ship on Earth. That is exactly why the Navy keeps improving radar discrimination, software baselines, missile mixes, and testing. The goal is not fantasy. The goal is to keep raising the threshold required to kill an American ship. To force the enemy to launch more weapons, coordinate more perfectly, and spend more resources for a lower chance of success. In that sense, taking down 100 missiles is really about deterrence. If the enemy believes the destroyer can survive and shred a huge raid, he may decide not to launch it at all. And that brings us back to the title. How can the US's most powerful destroyer take down 100 missiles at once? By not thinking of missile defense as one shot, one kill, one target, one moment. It does it by combining the Spy-6 radar's all-around multi-threat vision, the Aegis Combat System's automated decision chain, the 96-cell Mk-41 VLS, the layered standard missile and ESSM family, and a crew trained to fight through chaos instead of freeze in it. It does it by firing in layers, by engaging concurrently, by managing the raid instead of being buried by it. And it does it by turning a destroyer from a mere warship into something much more dangerous. A moving anti-missile fortress that sees farther, thinks faster, and shoots smarter than almost anything else afloat. So the next time you see a Burke-class destroyer slicing through open water, remember this: you are not looking at just another gray hull. You are looking at a warship built around the assumption that the opening minutes of the next naval war may be a storm of incoming missiles. And rather than avoid that storm, the newest American destroyers are being designed to stand inside it, sort it, fight it, and survive it. That is what makes ships like Jack H. Lucas so frightening. Not that they are impossible to kill, but that killing them may require a level of speed, volume, and precision that few enemies can actually deliver. And if they fail, the destroyer is still there, radar alive, magazine loaded, and ready to answer fire with fire. And maybe that is the real reason the destroyer matters so much. It is not only a ship that can shoot. It is a ship that can keep the rest of the fleet alive long enough to keep shooting back. In naval warfare, that difference is everything. Because the side that survives the first raid usually gets to write the rest of the battle.